Welcome to this lesson on the mean in statistics. The mean, also called the arithmetic mean, is one of the most fundamental concepts in statistics. Let's start with the definition of the mean. There are two main types of means we work with in statistics, the population mean and the sample mean. For a population of size n, with values x_1, x_2, and so on up to x_n, the population mean, denoted by mu, is the sum of all values divided by n. For a sample of size n, with observed values x_1, x_2, and so on up to x_n. The sample mean, denoted as x bar, is the sum of all sample values divided by n. Let's try to understand the mean intuitively. Imagine we have 5 data points, 2, 4, 6, 8, and 10. We can visualize these on a number line. To calculate the mean, we add all values, 2 plus 4 plus 6 plus 8 plus 10 equals 30. Then we divide by the number of data points, which is 5. So our mean is 30 divided by 5, which equals 6. The mean is like a balance point. If we imagine each data point as a weight on the number line, the mean is the point where the number line would perfectly balance. Let me show you more clearly what I mean by the balance point. Imagine a seesaw with weights placed at the positions of our data points. If we place the fulcrum at the mean value of 6, the seesaw will be perfectly balanced. This balance happens because the total moments on both sides are equal. Mathematically, the sum of distances to the left of the mean multiplied by their values equals the sum of distances to the right of the mean multiplied by their values. Let's work through another detailed example. Suppose we have the sample data, 2, 5, 7, and 10. To find the mean, we add all the values, 2 plus 5 plus 7 plus 10 equals 24. Then we divide by the number of data points, which is 4. So the mean equals 24 divided by 4, which equals 6. One important property of the mean is that it's sensitive to extreme values or outliers. For example, let's take our previous data, 2, 5, 7, 10, which had a mean of 6. Now, let's add one very large value, say 96. The new mean becomes 2 plus 5 plus 7 plus 10 plus 96, all divided by 5, which equals 120 divided by 5, which equals 24. Notice how significantly the mean shifted from 6 to 24, just by adding one extreme value. This sensitivity to outliers is an important consideration when choosing which measure of central tendency to use. Besides the arithmetic mean we've been discussing, there are other types of means used in statistics. The weighted mean gives different importance or weights to different values. Its formula is the sum of each value multiplied by its weight, divided by the sum of all weights. The geometric mean is the nth root of the product of n values. It's useful for rates, ratios, and exponential growth. The harmonic mean is n divided by the sum of reciprocals. It's useful for rates and ratios, like average speed calculations. But remember, the arithmetic mean we focused on today is by far the most commonly used average in introductory statistics. To summarize, the mean is a fundamental measure of central tendency in statistics. It represents the balance point of our data, but is sensitive to extreme values or outliers. Understanding the mean is crucial for data analysis and interpretation in statistics. Thank you for watching this video on the mean in statistics.